Howdy do. This week on Werner's Whirligigs, we get the mill head back together. Almost.
In this episode, we'll assemble the millhead, remove and install that sneaky millhead transmission, install a bearing using extreme heat and cold, turn a spacer on the lathe, and learn how to choose which side of a snap ring goes up. Alright, hold on to your handkerchiefs.
I want you all to remember that I'm just another yokel who's not educated nor a professional in what I'm doing here, and it's possible that if you rely on this video, you, your project, or the both of you might end up as a smoldering hunk of hammered dog shit. Please use common sense, be careful, and always protect your ears, eyes, face, body, and hands when doing this type of work. With that, let's keep on trucking. This video may contain peanuts. Well, hello. Welcome to Werner's Whirligigs, or welcome back if you've been here before. Nice to see you. I'm Werner, and this episode we finally finished taking apart the millhead. Thank you to Eddie the Grouch, who helped me with some final steps, and then we put almost the whole thing back together. It took a little bit of patience and thoughtfulness to get it all back together. I even had to repair some parts and make a couple new parts, but that's part of the fun, right? So let's jump in and see how it goes. Based upon some really good comments from a guy named Eddie the Grouch in my last video, I believe my next step is to remove this fine feed screw. So this is like a screw gear in here. I don't know that you can really see it, but when you turn this screw, it causes a brass gear, the brass gear in there, to turn, and therefore the whole shaft to turn. So we're going to try to push this thing out with my hydraulic press. Okay, what you're looking at now is the opposite side of that screw. We were looking at the side with the handle before. This is the other end, and I've got a punch set up to push the screw backwards and out, and I've disengaged the brass screw so it's free to turn while I'm pushing out this screw. So let's see what happens. Let's take a breather here and see what we've got going on. Is this magnetized or something? Oh. Okay. Oh, yeah, it fell out when I picked it up. So it's out now, and what we have left is this hole here, which is not all that impressive. However, what is impressive is that the shaft comes out. So here's what we're left with now that this has been separated. This is that block or transmission block where the fine feed and the coarse feed come together. This is a bushing in which the screw here rides on, and this is the gear and the shaft. So this is where the fine feed mates up like this, and as it turns, it causes this to turn, this brass gear, which in turn moves the entire shaft and therefore the quill down. Anyway, it is officially apart. Now it's time to put it back together.
We're putting the band back together.
Forget it. No way. We're on a mission from God.
We are officially in rebuild mode now. So I'm going to do the bearings. I have this little needle that's hooked up to my grease gun, and I'm just going to fill up the spots between each of the bearings with grease, and I'm using a high temperature high temperature grease. It's called 105 something or other. But I got it at a bearing house last time I went to go buy some bearings, and they were pretty fond of it. So that's what I'm going to use. Now we're going to hit the other end. Now we're going to do the same thing for the ball bearings. All 4 of these bearings are now packed full of grease. We'll also put a light layer of grease in the bronze gear. Let's start putting this block back together now. No rocket science here. We just want to get the gear lined up in here in the same location as where this goes. Then we'll just spin this in. You can see it's already gone all the way through. So really just we need to push this thing in. And in our case, the threads are going to be up, and we want them to line up with the threads over here, thread holes over on the side of the block. Before I go jump on the press, let's just see if we can knock it down. Yeah, no problem. Not bad. Finally, the locking screw. I think it's giving me troubles because I may not be perfectly lined up. But let's try again. Well, I think this is as good a time as any to stop for lunch, because I can't get this in yet. I'm back from lunch, and a little time to think about it helps. I came back out here and looked at things more closely, and the threads between the bushing and the actual body of this block were misaligned a little bit. So I just tapped in the bushing a little bit more, and things lined up. Easy peasy. Okay, I've learned some lessons today, and so far I think the most important lesson is there is a certain order that things need to go back together, and you cannot deviate from that order or you'll get stuck. I think I've gotten stuck 3 or 4 times now, and so I'm basically back to almost having a bare milling head. The only thing that I have together still is the feed block. So before you do anything, you need to put in the quill. And I'm finding that if you kind of spin it a little bit, rotate it just a little bit as you're feeding it in to get it started, it for some reason seems to do better. Okay, and then we're going to put in this guy, and this just keeps the quill from rotating. You don't want to tighten this all the way down so that it keeps the quill from moving up and down. You do want to have it in far enough so that it lines up in the keyway and the quill doesn't spin around here inside of the bore. Now what we're going to do is slide in the shaft for the feed shaft, and it comes out the other side, and we're going to find our 5 by 50 millimeter socket head cap screw and get it in here to hold the feed block in place. There's no reason why we can't tighten it down now. Okay, and then the next thing we're going to do is put the flat ribbon spring on the other side. And just note that there's these divots here, and we're going to use those to lock the spring body in place. I ran into another issue. This is the ribbon spring, and it has a crack on one half of it right here. I just got out my TIG welder and practiced trying to weld together two razor blades, and it was a fantastic failure. Actually, I got them to stick together, but I just wasn't strong enough. I could wiggle them, and eventually they broke. So I think what I'm going to do instead is drill a couple of holes of similar shape, one of the small diameter and one of the large diameter, just a little bit further down this way, and then I'll cut off the end of the spring, and we'll just lose about a half an inch worth of spring. I don't think that's going to be enough to change the overall performance of the spring. Well, for better or worse, the spring unwound. We're just going to drill some new holes, as I mentioned earlier, and here's the original and then mine. Not quite as neat and tidy, but I'm not going to clean up those little corners because I just don't want any chance of that screw head slipping through, so I'm going to leave them there. Last thing I need to do is now shorten this. I grab my metal shears and just cut it off, and then on my belt sander just smoothed out the end. So hopefully this is going to work just fine. Well, I just wound the spring back into here but without filming it because it's kind of messy. And but anyways, what I did is I put this piece right here in my vase, and then I fastened the outside of the spring here, and then I just wrapped and wrapped and wrapped, and it was really an exercise in brute force, but I got it done. And so now I need to put this this screw in here where the end of the spring grabs on, and the way I found the best way to do this is just to grab it with these needle nose pliers, and then just get it started. And once it's started, it's still tricky, but at least it's not as tricky. Okay, I'll leave it there. It's gonna, once the spring is lashed onto it, it's not going anywhere because there'll be so much resistance on the screw that I don't think it'll be able to spin. But that's just my conjecture. So while we're here, why don't we just go ahead and fasten on the spring? And the way I found the best way to do it is just to get it down here and then turn the shaft, and I did it in this case by pulling on the quill, and now it's locked up in there. And then we're just going to button this thing up. Now, we may have to go back in here again, I'm not sure. I know we're going to have to tighten up that spring, but I don't know that we need to do it with the cover off. Now we're going to drop the handle on. Before we do that, we're going to put in this key, and you want to be sure that the little machined conical point in here, or conical hole, is closer to the main body of the lathe. The mill head, and that's because it has to line up with the handle. There's a hole in the handle that's going to lock into here. Then we slip on the dial, and then the last thing is this handle. I finally figured out what this second hole does. This set screw in here, which has a flat bottom like this, actually drops down in between the gear, one of the gears, and another surface in a groove between the two. And so this is not actually pinching on anything. It's just an alignment so that the shaft doesn't slide from left to right anymore. And now we're going to set the tension on the spring for the quill. So notice that when I drop this down, it doesn't go all the way back, and that's not quite what we want. So what we need to do is we come over here, there's this set screw again that locks into conical divots on this thing inside of the body of the mill, and we want, let's see, we're going to want this to be tighter, which will be rotating it this way counterclockwise. So we're going to loosen this up a little bit until this can spin. There it goes. Oh, other way. We want to go clockwise, excuse me. Okay, that's... And then you just kind of turn it until you find the divot, and then you tighten this in. So you also need to be careful that these springs don't come out, and of course you can, once the cover is on, they won't come out. So let's see what happens. So maybe we'll do one more little divot because it's not quite going all the way back up. So again, recall we're doing it, let's see, turning it clockwise. Okay, here's the next divot. Okay, that's going all the way up now, all the way down, all the way up. So we might as well finish up the handle. And recall that there are two flatheads, flat blade set screws that go in here. One of them, and it's not that one, just has a conical tip, and this is the conical tip that I was referring to earlier that inserts into that key that's sitting on the inside shaft. So we'll put this one in first. For no other reason that it was the one I picked up first. Okay. Okay, and this one is a little bit more special. I recall that this one is what causes this to fall into a detent. So first thing here I have is a ball bearing that goes in. Almost snuck back out on me. And we'll put a little bit of grease on that too. Okay, then we're going to put in the spring. And finally, the other set screw, which has a flat bottom. This is also takes a flathead screwdriver. The other one is conical, has a conical bottom. This one has a flat bottom. And I don't know if you want to adjust this. I say you or I want to adjust this. Let's put on this handle and see how it feels. To move this through its range. Doesn't feel bad. It feels just fine. And again, this is the selector to switch between the coarse feed on the handle and the fine feed here on this little fine feed shaft. All right, and then we're going to put in these two bolts here. They are 6 by 30. And these two accompany that 5 by 50, that really long 5mm set screw that is hidden underneath the dial. Okay, so the last thing we need to do is put on the fine feed handle. This fine feed handle goes on as such, but you need to be careful. This pin really only goes one way. So see, it won't fit in this way. Probably will fit in this way. No, not really. So, okay. In this case, this is the leading end, and we need this to be on pushing through this way, and then on this pin, or on this hole here, okay, and that's the way through. Alright, that went through pretty easily. Just grab a little bitty hammer and give it a little bitty tap. That's all it needed. Okay, so now when we... There we go. Now when it's locked in place, we can manually feed the quill up and down. And when we pull this out, then the handle moves it up and down. Let's continue to work on the quill side of the mill head. We're just going to put this cover back on, and it has two flathead set screws on either side, and there are holes out here where this fastens. And also be aware that there is, see if you can see it in the light, there is a felt washer in here, and I'm not going to change it. I'm just going to leave it in there and slide this on, making sure that the holes line up correctly. And if we're lucky, it'll go right in. Perfecto. Now that we've finished covering up the bottom of the quill, we're going to focus on the top end. We're going to install a washer that has some tines on it and this spindle nut, which is a spanner nut. When putting this together, pull up and down, wiggle. There should be no up and down movement of the shaft and the bearings inside of the quill. And at the same time, this should rotate freely. So if you can move it up and down, that means your bearings are not close enough together, and you're going to want to push this bearing down in a little bit more. The other end is fully seated against the shoulder, so you shouldn't be moving that one. Once you have that play taken out, then we'll go ahead and install the washer and the nut, really only so that there's enough pressure on the nut to keep this bearing from moving. We have this washer here with tines, and then we have the nut, and you can see there's two different sides to the nut. One is angled and one is square. The angled side goes down, and you can think about it, it sits kind of like it's sitting in a basket of these tines, and the central tine lines up in a keyway in this shaft. So make sure that the washer is all flattened out and straight. so that there's no wave here in the main part of it, and then bend these tines up just a little bit. Install the washer, and again there's a slot here, so we want to push it down so that the inside tine lines up with that lines up with that groove. Then take the nut, put it with the angled side down, and we're just going to screw it on until it bottoms out. I mean, really, I don't know that we want to go any tighter than finger tight. What I'm going to do, feel this, and then I'm just going to tighten it until we reach the next tine, which is I'm just going to be moving it over here just a hair. Okay, and there's, again, still no free play. And then I'm going to just go around and flip up these tines. So the first one's going to go into a notch. And that's the only one that's actually going to mate up with one in the notch. And the rest of them, you're just going to bend up until they're touching the bottom of the nut. And for these other tines, the reason that they're there is if for some reason the nut starts to back off, then you want these other tines to be able to catch the spanner notches so it doesn't continue to back out. So once this is fully seated and tightened down, then you're ready to move on to the next step. All right, we've got the bearing holder in place for the Quill side, and this bearing goes here. It's time to start installing snap rings. And just a quick refresher here, recall that a snap ring has two slightly different edges on it. So one edge, this outside edge here, or the inside edge for that matter, it's the same. And in this case, this is actually the inside edge, is where the force will be applied. One side has a very sharp 90-degree edge, while the other one has, on the other side here, has slightly rounded. And in this case, this bearing is going to be coming out. This is going to be installed into this groove. You can see under here, and it's going to be pushing this way into the groove. So we want the sharp edge pushing this way into the groove. I'm running into an issue where as I apply pressure, I mean, having this ratcheting pair of pliers is awesome, but as I apply it, this snap ring tends to want to twist like this. And in doing so, it comes off of the tine on the pliers. So what I found, and I just figured this out, and maybe other people know this, but it's new on me. Okay, if I put the snap ring down like this so that it can't push away too far, and then I open it up and I'm helping it around, yeah, there it goes. It worked. This next step I had to ponder for a moment. This part of the bearing and holder fit on here, and then the pulley fits on top and needs to be pressed down. There are 4 screws here that hold this bearing cap or whatever bearing holder in place, but you can't install the screws once the pulley is installed on top of the bearing. So the question is, do I install this, put the screws in, tighten it down, and then press on the bearing, or do I put the screws in here like so, and then take this over to the press, press the bearing on, come back, slide it on, and then use a crescent wrench to install the screws. I guess the other option would be to throw this thing in the freezer and heat this up and see if it just drops on. That might be another way to approach it. Okay, time for a little fun. This bearing and the cap here were sitting in the freezer overnight, and I'm bringing them out here, and I'm working quickly because I also have the pulley sits on top of this, sitting over on a heater. First, take it out. We're only actually 10. Hopefully it doesn't fog too much. I would have never thought that could take so long. Okay, so the pulley is over on a heater right now, and I'm going to bring it over and drop it on. Hopefully it just slides on, but we'll see. Success, it worked. Oh my goodness, that was good. And I'll just tap on it a little bit just to be sure it's fully seated. Getting excited. These are the parts that we have left for the Millhead, and let's see, I think we're going to start by taking this cap. We'll press the bearing into here, and then once we're done, we'll take this piece, which is the pulley, and press it through here into the same bearing. Before we install this on the body, we need to put this little key in here, and it has there's a hole right here where it fits in place. So I put some grease on this to make it more sticky, and hopefully I can just push it along and it'll drop into place. And wow, it actually worked. So you can see it in there, and you can see the little nib sticking out here. So this piece is now complete, and we can install this on the Millhead if we desire. So then let's do that. Okay, the flat sides go in the front and back, and the rounded sides go at these ends. The goal is not to tighten them all the way until we get all of them started and most of the way down. We just want to leave some play again in the piece so that if we need to shift it around to get the last screw in, that we can. Once again, the parts pile is smaller. I think our first step here is going to be to drive this in. Now there's a bearing right here, and the outer shell is going to end up seating in this here. So there's no bottom. You can't bottom it out. And I don't know that that matters. The top is, we just need to make sure the top sits up here. So I think I'm just going to tap it in. I'm concerned that the bearings may have slid on the shaft slightly, and that's important because ultimately that determines where this gear is going to end up. It needs to mate up with this gear right here. So we'll start, I'm going to take a measurement of how deep this is. We just want it resting or hanging right above it. So 35.7 millimeters. But before we do anything else, I'm going to preserve the relationship of this bearing to this cap by setting in this snap ring. Already I noticed earlier that this bearing had moved up in this cap a little bit, which is how I started to think that things might have gotten moved around. Okay, so now this is seated in here. The bearing and this cap again can't move in relation to one another. However, the shaft can move up and down inside the bearing. So knowing what we know now, I just don't like the fact that this bearing is sticking out of the bottom of this. It doesn't need to. So I'm first just going to push that back down until it's at least flush with the bottom of the stick out. Now, I don't think there's anything wrong with going in further, but I'll stop there for the moment. I went back and reviewed my first video when I was disassembling this, and I found something that I just hadn't even noticed. There actually was a gap between this top cover here and the body of this riser, and there were 3 set screws in here in addition to 3 regular flathead screws that were holding this clamp together, or holding this cap on. Again, there were 3 set screws that were actually limiting how far this thing could go down, and I guess that's part of the mechanism to adjust the depth of the gear to make sure that it interacts with the bevel gear on the transmission correctly. So I'm going to install the set screws and also the hold down screws and think about it from there. 6 holes here, 3 of them are threaded and 3 are not, and obviously the screws that are meant to hold things together with this flathead top go through this cap here and screw into the column, and the set screws simply thread into this piece here, and then again you act as a stopper to hold this up above the column. So I guess actually I'll do these set screws first, since they're used to adjust the height, and I'm going to just set them to roughly what it looked like in my video from before. They were mostly in. There was, I don't know, maybe 1/8 of an inch sticking out.
The best way that I can think of to make sure that the 2 bevel gears are aligned correctly is to use some Prussian glue and then turn the gears together and see where the marks are made or transferred. Now ideally on a bevel gear you're going to want to see the intersection between the 2 gears here. So in the middle sort of front of the tooth, and it should be oval shape, elongated and oval shaped. So we're going to brush this up with a little bit of blue, I'm not going to go crazy, and run over to the mill and see what it looks like. Now I'll be honest, I've never done this before, so I might make a mess, who knows. I'm not going to do the whole gear, just a couple of teeth. Hopefully the shaft is straight up and down, and It won't vary from side to side. All right, let's head over there.
We're going to lower the tower on. I'm going to do it so that the blue is not touching the gear. So the blue is over here now. And then I'll just rotate it 180 degrees. I don't know, in this case, I don't think it's going to make a difference to bolt this down. I could be wrong. So I'll just turn it through its paces 180 degrees and see if that is enough to imprint. Now, I wouldn't say it's easy to see, but I can see blue here, 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 here. So that would tell me that we need to drop the gear down more. It's too far out and it's hitting this part of the tooth. So we're going to make some modifications. I dropped the shaft, the central shaft with the gear down a little bit. It was not measured. I just tapped on the end with a hammer and noted that it moved a little bit. And let's see, what do we see now in here? Well, obviously it was too low, because around the perimeter here we see blue on the bottom, so it was rubbing on the bottom. What about the gear? All right, here we can see the gear. I don't know how well this blue shows up on the camera, but we can see this pretty much the majority of the tooth has blue on it. I've blued up the gears again, and we're going to do the same thing every time. I'm putting the block on the same way. Okay, settled in. Okay, and then I'll spin it. 1, 2, 3, 4. Go the other way. 1, 2, 3, 4. All right. This one's a little messy. I can see, just don't see as good of an imprint this time. And here's one. I might suggest it's low. I mean, they're covering most of the tooth face, but it's not obvious. There's also a ring again around here, which to me makes me concerned that it still might be touching the bottom. It's not blue like it was again, but still I feel like I should raise it up a little bit more. I raised it another 0.5 of a millimeter, and the marks here, you can see them here and here. Actually turn the light on. I raised it 0.5 millimeter now, and we can see where the marks are. It's kind of tricky to see some of them, but it still, in my opinion, looks like it's a little bit low. It feels better, but I'm just going to raise it up a little bit more still. Okay, I think we're finally there. I realize now why there might have been some problems seeing the blue marks on here. They're very light, and it's because this gear is riding in an oil bath. It's not obvious when you're turning it slowly, but if you turn it quickly, it carries the oil up to the top. So it's a little confusing, but I don't know if you can see this, but there's a mark right here. It's up off of the very bottom now. Here's one, another, here again. We do want it to be not centered necessarily, but a little bit downslope. So I think, here's another one. I think as hard as this is to see, there's one. For my eyes, this looks correct. So we'll stop here.
After our last effort, we're basically down to a very small handful of parts. This collar, which is used to raise and lower the mill head on this tower. So this is the tower that sits above the transmission and the lathe mill. I've been wondering the whole time about these parts here. What is the purpose of this ring? We looked at it briefly before. You know, there are 3 screws that go through here. They're not, this part isn't threaded, and they thread into the body of this tower and keep this part from moving out. And then we have these 3 set screws which are threaded through this, and they keep this bar, or this large circular plate, from going this way. And I've wondered, why does that matter? So I think I figured out why this hardware is here. These 3 set screws and the 3 flathead screws, and they're, I mean, it's obvious, but to make this plate adjustable so it can move up and down. Now this plate, actually, it's more than a plate. It has a recess which captures the bearing inside, and then there's a circlip here too that holds the bearing into the recess of this piece of metal here. So the bearing is actually captured inside of this plate here. Now we need to install a washer, a lock washer of sorts, like we saw in the earlier with the tines, and also then we have to put on this nut. And what I'm thinking is that if, for example, this piece were lowered, you know, if this cap were gone, then the bearing, which would also be moving in that direction with it, would be too far away from these threads to make the nut function appropriately. So I think this adjustment is just to help align the top surface of this bearing, or put it in the appropriate distance from these threads here. So we do have a problem though. This washer, you can see the internal tine is broken, and so if it fits into this groove, and here where the threads are, where the diameter is slightly larger, it won't spin. It's fine. But if we drop it down to the bottom here and it's below those threads, then it can move, and then it won't do its job of keeping the nut from backing out. So to resolve that, I think we need to put in a spacer to move this washer up slightly. I think about 3 millimeters. So I'm going to use the Smithy lathe to turn this spacer, and it's going to be roughly 20 millimeters on the inside by 28 on the outside, and a 3 millimeter depth. All right, we're starting here at 30.5 millimeters, and I already took a cut. I thought the camera was on, but it wasn't, so we'll take another. Perfect, 21.6, and the OD on that is over there is 21.7. So that's about where I wanted to land, just a little under. And now we're just going to take up care of cleaning up this end. And now we're going to work to bore this out to a 20 millimeter ID. So we'll go as large as we can with some drill bits, and then we'll have to use a boring bar to finish it up. I got the drill in there just big enough to get my boring bar in, and so now we're going to go at it with the boring bar to widen out the hole to 20 millimeters.
Alright, we've got the right dimensions, roughly 20 by 28, and now we're going to cut this off. The drill bit is just in there to catch the ring. So let's give it a shot. Alright, I've got one of the two spacers set in my mill. This is a Delta Rockwell, what is it? It's like a 21-100, or it's the one that's only a vertical mill. It doesn't have any horizontal capacity. Anyways, we're just going to try to knock this off. I've just got it fixtured up on a set of parallels and then squeezed between the vice jaws. Hopefully it doesn't go flying when I start it up. Alright, we'll drop it down a little bit. I'm only taking 10 thousandths cuts because, or I guess 1/100 of an inch cuts, because I don't want to knock this thing out. It's a little delicate. Well, this little spacer turned out very nice, I think. I needed to go around the inside and outside edges and clean them up a little bit with a file and sandpaper. But yeah, other than that, it was pretty good, and it just drops right on. And more importantly, when I put this washer on now, it can't spin anymore. So that's exactly what I wanted to happen. So all we have to do now is put on the nut and set this up, and we are just about done here. With this part. We got so close this week. I thought we might actually get the Millhead on and get this thing leveled up, but we're not quite there yet. Even though the challenges that we had weren't too bad, they were kind of fun. It just eats up time. I actually spent a significant amount of time working on this since my last video, and even with that, I just couldn't get there. So I'm going to need to finish editing and get this video up on YouTube tomorrow, and then we'll have hopefully just one more video putting the milling head back on and tramming it and taking some cuts. So if you watch this far, thank you. Thank you very much. I really do appreciate you guys sticking around. If you enjoyed the video, give me a thumbs up down below, and subscribe if you like. Every 10 days on the 1st, 11th, and 21st, I release a new video, and we're going to be running the gamut. I've got stuff on BMW 3 Series coming up, a 1954 Chevy pickup truck, my 1993 Dodge Cummins diesel, and a whole bunch of other projects. I have so many. Well, again, thank you, and I'll see you at the next one. So long for now.